Roughly 380,000 years after the Big Bang, the universe underwent a quiet transformation. For the first time, it became transparent. And in that moment, a picture was frozen, a portrait of the entire cosmos as an infant. That image is the cosmic microwave background. Since its discovery, scientists have worked tirelessly to map it with incredible precision. Satellites like COBE, WMAP, and Planck have scanned the sky, measuring tiny variations in temperature, fluctuations no more than 1 part in 100,000. To the naked eye, the CMB might look uniform, a soft, even glow. But zoom in, and you find a landscape of delicate ripples, minuscule differences in heat and density scattered across the cosmos. And those ripples? They are everything, because they were the first seeds of structure. The places where matter gathered, where gravity slowly pulled atoms together, where galaxies would form, where great cosmic voids would open. Every spiral galaxy, every shining star, every living planet, each began as a whisper in that ancient light. It's strange to think about that the structure of today's universe, the cosmic web of filaments and clusters, all began with these subtle imprints in the microwave background. But those ripples weren't random. They came from something even more profound: quantum fluctuations. In the earliest fractions of a second, the universe was unimaginably small and ruled by quantum physics. Tiny, probabilistic disturbances in energy danced across the infant cosmos. And then, in an instant, inflation began. The universe expanded faster than the speed of light, not through space, but of space. And those tiny fluctuations were stretched, amplified, scaled up to cosmic proportions. What was once smaller than an atom became the blueprint for stars and galaxies. So when we observe the microwave background, we're not just seeing the first light. We're seeing the fingerprint of quantum mechanics etched onto the sky. We're witnessing the moment when the smallest forces shape the largest structures. It's like reading the universe's baby photo and seeing the genetic code that would define its growth. This is why cosmologists treasure the CMB. Because it tells us not just about the past, but about the rules that governed that past. It shows us the balance between matter and energy, the shape of space itself, the age of everything. From those faint ripples, we've calculated the curvature of the universe, its density, its rate of expansion, even its likely fate. And still, it humbles us, because no matter how deeply we study it, the microwave background remains a quiet echo, a message from a time before stars, before light as we know it, before structure itself. It is the oldest story we can read, and one of the most profound. When you look up at the night sky, remember, behind every star, beyond every galaxy, that ancient glow still lingers. It wraps around us in every direction, a halo of history, a reminder that everything we see began as something small, gentle, invisible. And from that gentleness came everything. The ripple became the web, the whisper became the symphony, the flicker became the stars, and somehow, billions of years later, one small species on one small planet learned to read it.